Hello, everybody. Here's a problem that somebody sent me today, and I thought it'd be good to include a video about it on Canvas for everybody to see. Um, and the way it works is we're given these two matrices, A and B, and it says multiply A times B and B times A if possible. Okay? So let me talk about some general ideas leading up to this and show you how to do this problem after that, okay? And I'd have to say, for some context, like, it's not like you multiply any two matrices exactly the same way. It's going to feel a little bit different depending on how big each matrix is, okay? And so what I'm saying is that it might be good to see some of the other videos about how you multiply matrices and see different examples. And I think, though, in the end, you'll pick up on a pattern if you see enough examples and if you practice it enough, okay? The reason I say it like that is because I think if you just like try to find some kind of rule or something about how to multiply matrices, it seems very complicated. Like if you had to learn it from this, just in terms of general principles, I think it'd be difficult. Okay, so I'm not going to show it to you that way. But what I will show you will involve some practice and picking up on some patterns. Okay, so I wrote down this question on my whiteboard, and so we had these matrices A and B, and the first question, part one, was to multiply A times B. Now, first of all, each matrix has a size. A matrix has rows and columns. The rows go horizontally, left and right, and the columns go up and down. Okay, so that's what we mean when we say rows and columns with respect to matrices. So this matrix A is, we'd say, 1 by 4, and that means it has one row, okay, and 4 columns. Okay, all right, that's its size. For matrix B, I would say it's 4 by 1, meaning it has 4 rows and 1 column. Okay, so you can see that 1, 2, 3, 4 rows. Rows go horizontally left and right, but just 1 column. Now, if I'm going to multiply A times B, first there has to be some compatibility between them. Notice that in the question it says find or multiply if possible. So it's not like you can multiply any two matrices. They have to be compatible for multiplication. Here's what I mean by compatible. So matrix A is 1 by 4. Matrix B is 4 by 1. These numbers in the middle have to match. They have to be the same number. Notice that in this case, they're both 4s. And so that makes the multiplication possible. All right, so we can multiply A times B. The result we're going to get is these numbers on the outside. So like this number and this number. So 1 by 1. So we'll get a 1 by 1 matrix as an answer. Okay, so how do you do it? Like, can I say something simpler than this thing I showed you over here? Can I show you something simpler than that? All right, well, that's what I'm going to try to do. So here's the general rule. If I'm going to multiply matrix A times B, I'm going to multiply each column of B times each row of A. Okay? So here's what that would look like in this one. So I need to multiply each column of B, and there's only one column, times each row of A, and there's only one row. So how would I do that? Like, do they seem compatible? How would I do that? Well, imagine that if I could like pick this up and rotate it. Oops. So that it laid right on top of that. Okay, so I'm going to like rotate it around like that direction. Okay, and then it would be 2, 3, 4, 5. That's what I mean. So what we'll do is we'll multiply 4 times 2, and then we'll add 5 times 3, and then we'll add 6 times 4, and then we'll add 7 times 5. Okay, so that's my vastly simplified rule, trying to give you something easier than what you might find in a book or some other place. So I multiply each column of B, but I have to rotate that column so that it lays right on top of A, okay, on the row of A. And then I multiply those numbers as they line up. 2 times 4, 3 times 5, 4 times 6, 5 times 7. And then one final step is I add those individual results. Okay, so that's how we do it. All right, now, like I said, to fully pick up on that pattern, I think you'll need to see some examples in my other videos. Okay, but if you see it enough, you will pick up on the pattern. It might take some practice and so on. So, all right, I get 4 times 2 plus 5 times 3, and I just do the math there, and I get 82. I get a 1 by 1 matrix as an answer. 1 row, 1 column. All right, so how do we put this in MyMathLab? So let's go back over here. So I want to put my answer in. Which one of these buttons allows me to put a matrix in? It's this one. See how I hover the mouse over it and it says matrix? And this kind of looks like a matrix, but that one is absolute value, and that's not what we want. So we want to do matrix, but what kind of matrix do I want to put in? Rows, columns? Well, remember that answer I got was 1 row, 1 column. So I put that in, and what was that number? That number was 82. So then I put in 82. That was the number I got. So there's a 1 by 1, 1 row, 1 column matrix as my answer with the number 82. Okay, so let's have a look, and we'll check it, and it will be right. Okay, now what about the other way? What about B times A? So let's look at that one now. So that I've also written down on my whiteboard. Okay, so B times A, B here, A there. So what was the rule again? That the sizes of the matrices have to be compatible. So B is 4 times 4 by 1, 4 rows, 1 column. And A is 1 by 4, 1 row, 4 columns. And I said these interior numbers have to match, and they do. And the result is going to be 4 by 4. So whenever I do this, now I know I've got the answer right there and all the intermediate stuff, I'm expecting a 4 row, 4 column matrix, 4 by 4. Okay, but how do I do it? All right, let's look back at this rule. The rule said that we're going to multiply each column of this matrix times each row of that one. All right, so try to imagine how that would look. So each column of this one times each row of that one. If I was going to do that here, I don't have to rotate it. Like, what's this column times this row? 2 times 4, right there. Okay, and I continue. What's this column times this row? 2 times 5. What's this column times this row? 2 times 6. What's this column times this row? 2 times 7. All right, and continue. What's this column times this row? 3 times 4. This column times this row, 3 times 5. This column times this row, 3 times 6. This column times this row, 3 times 7. And I continued until I multiplied each column of this times each row of that. And that's the arrangement being 4 by 4. I'm going to get a 4 by 4 matrix as a result. 4 rows, 4 columns. Okay. Now, from here you might say, well, how come when you multiplied this column times this row, I added? Well, just because, like, if I, here I have to imagine rotating in order for the numbers to line up, and you multiply the numbers as they line up. But when there's more than one number, like if this column has 4 numbers in it and I rotate it and lay it on top of that one, yeah, you multiply the numbers, but in addition to that, you add their individual results. Okay. But down here, I'm just multiplying, this column only has 1 number, and this row only has 1 number. There's nothing to add. If this column had 2 numbers in it, and this row had 2, then we would multiply the numbers as they lay on top of each other, and then we'd add them together. Okay, so there's my answer. Now let's see how to input it. So let's see. I want this, right, matrix, and I get 4 by 4. So I'll just select it the right size, and it's going to look like that. And then I got to put my numbers in. So I'll do that. I'll pause to do that, and then I'll show you what happens from there. Okay, so I got everything in there like I need it to be, just like I figured it out over here. Okay, and so let's check it, and we'll see that it's right. Okay, so that's how we can address this one in comparison with some of these others that I've already made videos for on MyMathLab. So look at all of them. They all have the same elements to them, but they're all a little bit different.